Hello, calculus fans. Okay, we're continuing on with what we had talked about in the last video. What we want to do now is compute dy by dx for the function y, which is implicitly defined by this equation. It's implicitly defined because we don't have a way of solving for y. If we're given a value of x, we could in principle solve for y, but we can't write it as a general function. So the method of implicit differentiation is that we're going to differentiate both sides with respect to x. Let's say a little bit about what this phrase means, with respect to x. All we really want to think about is that means that x is the independent variable and y is the dependent variable. You know, if you looked at this equation, there isn't really an independent variable and dependent variable that jumps out at you. So we're going to define x to be the independent variable. So when we differentiate with respect to x, if we differentiate y, our result is going to be dy by dx. Okay, so let's see the calculation now. So first we're going to just put the differentiation operator on each piece. So we have the derivative of 4x squared plus the derivative of y squared equals the derivative of 16. Okay, so let's try to simplify this. So the derivative of 4x squared, that's just 8x. Then we have to differentiate y squared, and we're going to end up with 2y times dy by dx. Now we'll describe that in a little more detail in a moment. That's basically coming from the power rule and the chain rule, but we'll see how that works. And then on the right-hand side, the derivative of 16 is just 0. Okay, so once again, I'll take a moment after we're done with the calculation to describe how we got to this step, because that's actually pretty important. If we go ahead and solve for dy by dx, we can move the 8x to the right-hand side and then divide by the 2y, and simplified, we get this expression here. So that's our answer. That's the derivative of y with respect to x. If you give me a point on that ellipse, the x and y point, and we plug it into this equation, then it's going to tell us what the slope is at any particular point. Let's go back now and talk a little bit about how we get from here to here. Okay, so the first piece is actually pretty straightforward. That's just a power rule. This piece takes a little more thinking. Okay, so we want to see how this works. All right, so the derivative with respect to x of y squared is 2y. So that first part is because of the power rule. We're just differentiating y squared, so the answer has to be 2y. And then we get the dy by dx out here because of the chain rule. Okay, so we're thinking of y as being a function of x. So what we really want to think is that y squared has an outside, that's the squaring, and it also has an inside, that's the y. So we've got the outside and the inside. Okay, so when we write down 2y, that is the derivative of the outside, and then dy by dx is the derivative of the inside. So if we differentiate y with respect to x, we're going to get dy by dx. We'll see a few more of these as we go on, but that's all for now.